Hello guys, welcome back. This is Rosario Borgesi, and today I want to explore with you the world of blockchain. We will discuss how the blockchain works, what are its main benefits, and also what are its main limits and challenges. And also we will also take a look at what are the solutions that have been proposed in order to overcome those limits. And we will also explore the main application areas of the blockchain. And I hope the video will be useful to you. So let's get started. I've created this medium story that will guide us throughout the video, in which it is explained in great details for obviously people who are totally new to the arguments, how the blockchain works, and all the topics that we have said before. So I would like to start with the core principles of the blockchain. What is basically the blockchain at its core, and then we will explore in the following more in details all these properties. The blockchain, it is a technology that it is basically distributed ledger with a list of transactions that is decentralized, and it is secure and transparent. So it basically allows us to transfer, as we will see later on, value and also information. And this information are immutable in the sense that it cannot be changed or deleted. And at its core, the blockchain, it is called this way, as we will see, because it is literally a series of blocks of transactions that are linked together by means of cryptography. The core principles of the blockchain are the decentralization, because blockchain operates on a distributed network of nodes, and there is no central authority. As we will see, this is the crucial point of the blockchain. And the transparency, because all the transactions on the blockchain are public and visible to all participants in the network. The data that are recorded on the blockchain are immutable in the sense that they cannot be changed or deleted. It is secure. It is secure because the encryption by means of the cryptography and the consensus mechanism protect transaction on the blockchain from tampering and unauthorized access. Also, the blockchain, it is based on a consensus mechanism by means of which the network nodes can agree on the state of the blockchain. All transactions are traceable and are recorded permanently, so we can have a complete audit trail. Each transaction is authenticated by means of encryption and network consensus, and this ensures the origin and the integrity of the data. And the blockchain, it is efficient in the sense that it eliminates the need for intermediaries and reduces the complexity and cost of the transaction. Also, this is a crucial point. The blockchain, it is trustless because it aims to eliminate the reliance on central authorities or third parties for trust. Now, we said that the blockchain, it is a distributed ledger. In order to understand that, um, we um, we can um, we can go back to the Yap Island of about 2000 years ago, where was developed the first distributed ledger. And if you like, you can also take a look at this video. But now we will see with an example how this works. So in this Yap Island in the middle of the Pacifics, there were no gold and no silver. So the people did not have practical currency like it has been in Europe, like our euros, for example, or USD. So they invented a currency which was constituted by rocks called rays that the Yapis people imported from the nearby island, and they were pretty heavy stones because they were something like 11 feet and tall and about 480 pounds of weight. You can see an example here. So they were grit stones that were placed all over the island. Imagine that they were fixed and they cannot be moved, and they acted as a currency because it worked this way. So each person, like you see here, knew what each stones belonged to. For example, let's say that the first rock, ray, belong to the people, the person, the black person. So each other person had to remember by memory that the first stone, the ray number one, belonged to the person in black. So let's write this here. Ray 1 belongs to black. Okay, so each person knew this information. Sorry, it is black. I wrote um, badly this, but it's okay. You understand. So each other person knew that the ray number one, this stone belonged to this black person. Let's suppose that ray number two instead belonged to the person in blue. So each one had to recall by memory that ray number two belong to blue. Okay, and so these all the other people knew this by memory. Okay, perfect. Now let's imagine that one person, for example, the green one, um, said no, the ray number two in reality belongs to me. That could not happen because all other person would say that this was wrong because they knew that the ray number 2 belonged to the blue person. And also, for example, if let's say ray number 1 was um, exchanged with some good, so it changed its owner. This change in ownership would have been recorded by all other people. So, for example, let's say that ray number 1 was transferred to the green person. So everyone would know that ray number 2, ray number 1, sorry, is transferred to green. So everyone would record this transferring, and basically this is what is intended with the distributed ledger. So the Japanese people about 2000 years ago invented by chance this distributed ledger that now, of course, it is not it does not rely on the memory of the people. Maybe after a while they used the books in order to record all this information, but now there are nodes, so computers that run the client software of the blockchain that record all this information. So each node of the blockchain records the entire distributed ledger. So if a person, as we have seen, tries to tamper with it, all other person that have their own version of the ledger, and it is the majority, would say, no, you have the wrong ledger, and so the right information would have been kept, and there is no way you can tamper with the transaction in ledger. So this is basically how the blockchain works. Now let's get back to our article. So obviously this distributed ledger gets updated continuously with each new transaction, and there is no way you can modify it. So this is what makes it secure and trustworthy, and obviously this allowed the Yapis people to do not rely on a single person or a single group of person to maintain the ledger, because this would of course create possible issues, because these people, this single person or this small group of people could act unfairly to others by modifying the ledger for personal advantage. So this is the, let's say, the genesis of the blockchain. But how this blockchain has been developed from from an architectural standpoint. The first blockchain ever created in 2008 by Satoshi Nakamoto is the well-known Bitcoin, which has been presented as a peer-to-peer electronic cash, which fundamentally consists in a network of nodes, as we said before, which are basically computers that are running the blockchain client software, and they can communicate with each other. But in order to do so, it cannot be used the client server architecture, because the client server architecture, like like most of the website that we use today, rely on a central machine, a central server from which all the clients get the information. So there is a client that requests a service from the server, and the server that replies providing this service or this data. In the peer-to-peer model, which is the one adopted by the blockchain, there is no client and no server. Each peer, which is each node, each machine, acts as both client and server, so it can request services from another peer, but it can also provide services to other peers, and so there is no centralization. This is why the peer-to-peer network has been chosen, and it was the only one that could support the blockchain. And of course, this allows the information not to be stored, the ledger not to be stored like here in a single place, but to be replicated on each peer, on each node, which has exactly the same ledger, the same copy of the blockchain of all the other nodes in the network. So, as we said before, this network is trustless. This means that unlike the traditional banking, where we deposit our money in the bank, then there are some third parties like Visa or PayPal that allow us to process our payments. Then the money go to the bank of the person or the company that we are paying, and these other people can access their money through the bank. So the blockchain wants to eliminate the intermediaries, and so there is just the network that allows us to send directly the money to the other person or the other business that we want to send our money to. So we've said that the blockchain is a network of nodes. There are various kind of nodes. There are the full nodes that store a copy of the blockchain ledger. They store and they act as validators, and they communicate with other nodes to ensure that blockchain is updated and accurate. And these are typically run by cryptocurrency enthusiasts, blockchain developers, organization, and so on. And this require, of course, a high level of security and control over the blockchain transaction. Then there are the light nodes, which are a lightweight version of the full nodes, and they just they do not download the entire blockchain, but a small portion that contains the information relevant to the transaction. And in fact, the light nodes rely on full nodes to validation and block verification. And they communicate with the full nodes in order to get the information they need to verify the transaction. So the full node not only download the entire blockchain, but they also verify the transaction, so they have a principal role. While light nodes are and they have to be these full nodes run on machines that have good hardware. But light nodes can be run also on for example, on a smartphone. So um, we on machines on devices that have limited storage and processing power, because um, they don't need to download the entire blockchain, but only the relevant part to verify their transaction. Then there are the miner nodes. The miner nodes are only in Bitcoin, because only in Bitcoin there is the consensus mechanism that is known as um, proof of work, also known um, as mining. And the miner nodes are responsible for verifying transaction and adding new blocks to the blockchain. And of course, for performing these operations, in fact, they need to solve some mathematical problem, as we will see later on. They receive a reward in the form of cryptocurrency. And in order to do that, the miner need specialized said hardware and software. We know that NVIDIA provides the best GPU in order to carry out the task of the miners. And of course, they are typically run by large mining pools or individuals who invest the resources in an equipment that has particularly important hardware. And of course, the miners have an essential node in Bitcoin. There is this video that you will find in the description that explains, if you would like to check it out, that explains how the blockchain works, but we will also see it. I will also explain it, so you will understand it also by watching this video. But of course, for to have a more complete knowledge, I suggest you to take a look at it. But the basic of the blockchain cryptography, it is the SHA 2056 excuse me 256 function that allow us to encrypt the data. For example, we can check there is an online tool here. You can put here whatever input. For example, I love Bitcoin. You can always have a string of this dimension, which, as you see, it is an hash. It is deterministic in the sense that each string produces just one output, but from this output you cannot get back to the input string. So whatever string of whatever size, whatever dimension, gives always the same output. You also here can paste the entire encyclopedia, and it will always give you the same size, string size in output. And so, as we said, the output is fixed, it is deterministic, it is resistant to collision, which means that the likelihood of two inputs that generate the same output is very low. And of course, the input can have any size. So, the blockchain structure, as we said, it is a sequence of blocks, as we see here, and that are interconnected. We will see how, by means, of course, of cryptography. And of course, each blockchain, the entire full version is stored in a node, as we said, the full node. A block, it is a data structure that basically has the block number, which of course starts with the genesis block, which is the block number 1, and then um, sequentially it gets increased with each block. So each block will have a number that grows in sequential order for each block. And then we have the nonce that it is used in the that stands for number used only once, and it is used in the proof of work consensus algorithm. Then we have the data field. Well, there are basically the transaction where we want to where we express whom we want to transfer our money to. And then the most important the other two important field are the previous hash that allow us to link this block to the previous one, and so you get blockchain as we will see later, and then the hash of the block. So you consider all this information grouped together that are put here, and then you calculate the hash of the of a single block. And as we said earlier, the previous hash is what allow us to connect a block, a precedent block to the next one. And so this is the how the really the blockchain is created, because each block contains the hash of the previous block. So this is what ties together this information, and this is important because if you try to modify one block, for example, this is a node that hosts this blockchain. For example, this node wants to modify a block, wants to tamper with the information of this block. And so what happens that all the other blocks are not linked together. And so you will see from, as we saw in the example of the app Iceland, for the other nodes, not only the next block are not linked to this one, so you have to mine this and all the other nodes, but also if you compare this blockchain with the other on the other nodes, they are different. So you will see in a straightforward manner that this node is trying to tamper with to tamper the information in this block. So let's see now the demo. This is the site that allowed me to understand better the blockchain, and you will find it in the link in the description. So here we have the hash that we have discussed before, the block. You see, you have the block number, the nonce, the data, the hash, and of the block. What does it mean, the nonce? Nonce, it is a number that, for example, you here type a data. For example, I transfer, this is my transaction, I transfer 1 BTC to Paul, okay? And in order to mine this, what does it mean that you want to mine this block? You start from the nonce number 1, and you want here that the hash starts with a certain number of zeros. Okay, for example, let's say 3 zeros, but in Bitcoin this changes in order to increase the difficulty. For example, this does not start with 3 0, so I need to augment the nonce to 2. This node starts with 30, the hash. So I augment it to 3, then 4, then 5, and I continue to increase the nodes until I find, sorry, the nonce that creates an hash that starts with the desired number of 0, for example, 3. Since there is a competition between all the miners, the miner that finds first these nonce is the miner that solves the problem and can create the block and gets the Coinbase, which is the reward for mining for the proof of work, because it is called the proof of work because it is work that it has been carried out in order to solve this problem. But if we have I press mine, this will increase the nonce for me. Will continue that process that we have started before. Will until he will found the nonce that solves the problem. So if I press mine, you see he has found that 19,632 it is the nonce that will create an hash that starts with 4 zeros. So you imagine how much power it is required if you do it all days. So that is the reason why the miners need very powerful computers, because in order to solve this problem you need to continue to guess a lot of times. So here you will find blockchain. So you see all the blocks are linked together. You see the hash of the previous block, it is repeated in each block, and this creates the blockchain. Each block has a sequential number, so you start from 1 and you go until to the end. And this is the greatness of blockchain. If I modify block 2, for example, I want to tamper the information here. I write I send 2 BTC to John. As you see, this block is broken, so you have to remine it, but also all the following blocks. So I have to mine this again, because each block contains the hash of the previous one. This has to be mined again, this has to be mined again, this has to be mined again. So if we come back to the discussion, to the example that we talked earlier, if I modify a blockchain, so I say this, I transfer 1 BTC to Paul, and I change this, what happens? I need to mine, for example, let's imagine that this is an hacker that is trying to modify the blockchain. He modifies these 3 nodes, but I will see that this hash is different from this one, and since the majority of the hash has this hash here, which is different from the previous, I can in a straightforward manner understand that this peer here is trying to play dirty, to modify the blockchain, and this way he will be excluded. So now that we've seen how the blockchain works, let's understand how a transaction works. So let's say that a user has a wallet in his phone, which is basically an application that used to store your cryptocurrency, for example, Bitcoin. The wallet, it is an application that stores your private key, because the private key it is used to sign the transaction, and it has a public key. The public key, it is the like it is the address where you can receive the money. For example, here here let's understand how the transaction execution works. The user sends the transaction to the network of nodes of the blockchain. There is then a miner, as we have discussed earlier, that solves the puzzle. For example, in the proof of work mechanism, solve these mathematical problems, and what it does, it creates a new block in his own blockchain and then propagates this block to all other nodes in the network, which on their own validate this block and add this block to their own blockchain. So they match their own blockchain with the one of the miner. So all the blockchain are on the same level here, and that is basically it. So we have said that there is the necessity of a consensus algorithm, because the blockchain is not like a database. In fact, database is centralized. For example, if I am the admin and I want to give access to a person, I can do it in a straightforward manner. But in a distributed system, we need a mechanism of consensus in order to have to find an agreement between the nodes. So a consensus mechanism is a process that enables participants, which are the nodes of the blockchain, to reach an agreement on which node has the privilege to add a new block to the blockchain. It ensures that all nodes have the same version of the distributed ledger, and only valid transactions are added to the blockchain, and then the consensus mechanism is what provides security and fault tolerance to the network, preventing malicious actors from altering data or destroying them. There are two famous proof consensus mechanisms. One, it is the proof of work that we have discussed before. So there is a miner that solves the mathematical problems and gets a reward in form of cryptocurrency, for example Bitcoin, which is called blockchain, but requires an high energy consumption. Then there is another type of consensus mechanism. There are a lot of consensus mechanisms, but another famous consensus mechanism, it is proof of stake, which assigns the right to create a new block to a node based on the amount of cryptocurrency held at stake or locked at deposit. So, unlike proof of work, there is no work done by the node to solve a mathematical problem. It simply creates a new block. The more cryptocurrency is at stake, the greater the chance of being selected. So, proof of stake is more energy efficient and scalable than proof of work, but obviously can introduce security and governance risk because it is less decentralized, but instead it is more centralized consensus mechanism. As we said earlier, there are two types of economic incentives for the validators and the miners. there is the Coinbase, which is in Bitcoin, the amount of Bitcoin created after a block it is mined. Currently 6.25 Bitcoin, but in April there should be the halving, so it will be halved to around 3 Bitcoin. And then also the miner gets the transaction fees, because with each transaction we have to add, since the block it is limited, contains a limited number of transaction, we need to add the transaction fee in order, and there is basically a tip that we pay to the miner, and the higher the tip, the higher, the faster the block, there is more chance that the block will be added to the next blockchain. So if we want to be sure that in Bitcoin, for example, that our block it is added to our transaction, it is added to the next block, we need to charge higher fees. And because of course the miners will choose before the transaction that have higher fees. So the cryptocurrency, what are the cryptocurrency? The cryptocurrency have been created in blockchain to make it economically sustainable, and each blockchain has its own cryptocurrency. For example, Bitcoin, it is the cryptocurrency of the Bitcoin blockchain, while Ether, it is the currency of the Ethereum blockchain. The cryptocurrency, it is a medium of exchange, so it is a digital currency that enables transactions and payments within the blockchain network. And the user can transfer cryptocurrency to others as a form of payment for goods, service, or as a means of transferring values. Each blockchain has its own mechanism for creating cryptocurrency. For example, in Bitcoin, they are only created as a result of mining each block, making them a reward for the miners' work in solving the mathematical problems associated with the proof of work consensus mechanism. The most important blockchains are Bitcoin, which is the first blockchain created in 2008 by Satoshi Nakamoto, and now it is worth something like $1.5 trillion dollars. In fact, it is the largest blockchain per market capitalization. Its native cryptocurrency is Bitcoin, and is primarily designed as a new form of payment, facilitating transaction between users across the globe. And of course, if you want to explore more about Bitcoin, there is this book that is Mastering Bitcoin that I suggest, or also if you want to explore the economic aspect, you can check this article that I wrote, Bitcoin, a revolutionary currency for the digital economy. Then there is Ethereum. Ethereum, it is an evolution of Bitcoin, because Bitcoin was created basically to create a new currency that allows to transfer money between two parties by means of the blockchain, but we can also Vitalik Buterin in 2013 thought that it could be useful to use the blockchain also to deploy code, and which is called the smart contract, and to interact with this code. So the transactions are not only used to transfer value, but also to deploy code and to execute it. And this as the code in Ethereum, it is written in a programming language that is called Solidity. And of course, you will find in my channel is dedicated to the developing smart contract in Ethereum. So you will find a lot of interesting examples. And also, what is important, this has allowed the possibility to create two types of token. The fungible tokens, which means tokens that are each one equal to each other, and the non-fungible token where each token is unique, also called NFTs. These, if you would like to delve into it, have a standard on Ethereum which is ERC20, and this is ERC 721 on Ethereum. Also, if you like to learn more about Ethereum, I suggest you the book Mastering Ethereum. So, what are smart contracts? As we said earlier, smart contracts are just a piece of code. This is like a Java class. For example, when you have the name of the contract, then you have the variables, public or private variables, then you have the constructor, and then you have a function, which is the method of the contract. And basically, this is code that you can deploy on the blockchain, and you can also call the transaction. And of course, the transaction that read the data are free, but the transaction that change the state of the contract are payable transaction. Of course, you will find here links, if you want to know more about developing a smart contract. Then I would like to talk about the blockchain application areas, because this is a really cool technology, but we would like to understand how it can be used. It can be used, for example, in healthcare, because blockchain enhances healthcare by securely managing the patient record. Then in finance and banking, of course, Bitcoin was born in order to revolutionize this sector. So in the financial sector, of course, Bitcoin, the blockchain streamlines cross-border payments, reduces frauds, and improves transparency in transaction. Then in real estate, of course, with blockchain, the entire real estate process can be digitalized and with enhanced security and benefits, and the smart contracts can be executed between the seller and the buyer of assets for all transaction, and so we can eliminate the need for intermediaries. And also in the retail industry, the retailers can use blockchain for supply chain management, also for tracking goods from manufacturer to the consumer. In supply chain and logistics, blockchain improves supply chain efficiency, traceability, and reduces fraud by recording every step of a product's journey. This is important if you want to, for example, with expensive goods that are subject to fraud. In insurance, it is important because the insurance industry can benefit from blockchain by automating claims processing, preventing fraud, and enhancing transparency. In voting and governance, blockchain can revolutionize the voting system by ensuring secure and verified election, because it is immutable, it is public. In IoT devices can securely communicate and transact using blockchain, enhancing data privacy and trust. In media and advertising, blockchain enables transparent ID tracking, content licensing, and fair compensation for creators. And it can also help, this is important, to combat copyright violations in the intellectual property field. Blockchain can help manage copyrights by providing, of course, an immutable proof of the complete chain of ownership and ensuring fair compensation and efficiency in the execution of copyrights and related rights. In food and agriculture, blockchain can help to reshape the existing supply chains, payments, and tracking processes. The distributed ledger provides an immutable records of events from the purchase purchase of the seeds and raw materials to the harvesting of crops and supply of food products for sale, reaching cons- consumers. Travels and hospitality. The key feature of blockchain help maintain a distributed database of records, enhance security, eliminate the need for third parties, and improve the ease of accessing information from everywhere. So these are just an example of the application that in which the blockchain can be adopted, but they demonstrate how the blockchain can reshape our industries by providing trust, security, and transparency in a decentralized manner. Of course, blockchain is a relatively new technology and has some limitation. For example, scalability is the main limitation because, for example, Bitcoin can process 3 to 7 transactions per second, TPS, also called the TPS, whereas Ethereum manages 15 TPS. So these are in contrast, which is what they should aim to reach to, and is around 1736 TPS. And so there is a considerable gap between the blockchain and the transitional systems. And of course, there are some solutions that have been presented. For example, the layer 2 born because there are off-chain solutions like Lightning Network for Bitcoin or the roll-up technology for Ethereum. These allow faster and low-cost transaction without burdening the main chain. Then there is the sharding possibility which means to divide the blockchain to smaller interconnected shards, each handling a subset of transaction. And also another possibility could be to have optimized consensus algorithm, but the what seems the best solution right now is layer 2. For example, in Ethereum there are Optimism and Arbitrum, which are other layer 2 important solutions. Another important topic is the one of energy consumption, because the mining of Bitcoin uses approximately the same amount of energy as Argentina. And so it would rank among the top 30 countries for energy consumption. Some possible ways to overcome the issue, or even though they are just theoretical, because of course proof of work is what keeps the blockchain safe. Could be the transition to full stake, to use hybrid approaches, and also to use this is already been done. For example, there have been created some mining factories nearby volcanoes. For example, they use the energy of volcanoes, and also hydroelectric energy. It is used, so it is already used this. And but I don't believe, to be honest, that will ever change the consensus mechanism in Bitcoin, because it is what keeps it safe. Then there are, of course, some security and privacy risks. For example, because there have been a lot of there have been stored a lot of a lot of value. For example, for in Bitfinex lost 72 million of dollars in Bitcoin in 2006, and for example, also MTGOX lost um, 840,000 Bitcoin. So, but of course, this can happen in everything, and it can always happen that someone steals money to someone else. So this has to do with the creation of strong stronger security measure. Or for example, you can also record the crash of FTX, to give you another example. And other vulnerability exists, like the bugs in smart contract, the 51% attack, and of course the management of private keys, because you must understand that the private key must be kept private, because who owns the private key owns also the coins, not your keys, not your coins, and so the money should never, for example, be kept in the exchange, because like it happened in the FTX, if an exchange crashes, people will lose their money. So possible solution here are formal verification, so use formal methods to mathematically prove the correctness of smart contract, auditing and code reviews. So regularly audit smart contracts for security flaws, and use multi-signature wallets to enhance private key security by requiring multiple signatures for transactions. Other issues are related to privacy, because since the blockchain, even though the blockchain only exposes hexadecimal strings, which should be anonymous, they also could reveal details of the participants. Possible solutions are zero knowledge proof, because you can prove the validity of transaction without revealing specific details. Confidential transaction, so encrypt transaction amounts to enhance privacy. Sidechain and private blockchain, so use separate chains for sensitive data while interacting with the main public blockchain. Also, there are regulations and legal challenges, because blockchain operates across borders and makes regulatory framework complex, and possible solutions are collaboration with regulators, so engage with regulatory bodies to create clear guidelines, self-regulatory initiative, so industry association can establish best practices, and jurisdictional clarity, so to define which laws apply to blockchain activities. So we have reached the end of the video. I hope that it has been useful to you, and I encourage you to drop a comment below if you want to ask me anything, or you believe that something was not clear, and I will answer to you as soon as I can. And if the video has been useful, I would be very grateful if you would like to drop a like, and also subscribe to my channel, so you will get all the future updates. And thank you again, and I hope to see you in the next video.